Welcome back. Last time we talked together, we were talking about mixtures. And one of the things that we need to be able to do with mixtures, since they are not reacting with each other, that they are still different entities when they are mixed up together, is that we have to be able to separate them. So today we're going to talk about separating mixtures. How do we go about doing that? Okay? Now, to refresh your memory, two types of mixtures, homogeneous and heterogeneous, and they're based upon the components of what you can see with the components or not see with the components. Now, let's look at the four scenarios that we talked about in that last discussion we had. Now this time, I'm including the pictures that I used from the previous one. So you can just highlight that and click it into your address bar to see the pictures. If I like looking at sheeps and goats, I don't know why. Maybe I was from a long line of shepherds before we migrated into Scotland, and we may even had a lot of goats and sheep in Scotland as well. So that might be my particular inherent enjoyment watching sheep and goats, and all the others. So let's talk about this. We want to separate the water from the sodium chloride or table salt in the saline solution. So the question is, how are we going to go about doing that? So here's our saline solution. How do we go about separating the water from the salt, particularly since we can't see the salt? What do we have to do about that? Well, this is something that's pretty important because the vast majority of the world is not near a fresh water source. So they have to come up with a process of what we call desalination of water. Now what we're about to talk about is one, there are others that are much more complex, but this is the basic idea of desalination. So, we can accomplish this scenario of separating the water from the salt by two ways. We can boil off the liquid and save the sodium chloride, or we boil off the liquid into a container that will condense the liquid and then toss out the solid. The first process is called recrystallization. So if you boil off the water and keep the solid, then you're dealing with recrystallization. See if I can get that one right. Nope, that's the wrong way. So I'll have to edit this part out. Let's see. Nope. Oh, there we go. That's almost right. That's not it either. Okay, that's good. This is really nice. Strange. Okay. It's distillation. It's filtration. Okay. So I need to get the recrystallization back. This isn't it, this isn't it, this isn't it. Looking like a smooth run process here. So two stuff, liquid, so this is recrystallization back. Okay, so here's an example of recrystallization. What has happened here is that the water has boiled off, and we've got behind these nice pure crystals, completely clean. It's probably been washed out with another solvent, and then that was boiled off as well, something other than water, something that completely dissolved it, and then they boil it off and you get these crystals. This is how a lot of pharmaceuticals are made. When they are first made, they have a lot of impurities in it, but then they'll dissolve it in a solvent and then boil it off again, and your pure crystals, like how aspirin is made or any other pharmaceutical that is taken. Okay, so that is recrystallization. The other process is called distillation. Distillation is when we are boiling off the water, but saving the water and just chucking the leftover solid. We save the liquid, the water, whatever it is, and we get rid of the solid. That process is called distillation. So let's take a look at that picture of that. Buddy, okay, this is an example of the distillation. We have a mixture here, a homogeneous mixture. You boil it off slowly. It's salt water. What will happen, the steam will come up, and we've got this blocked off up here, but we do have an exit for the gas to go, the steam to go. So it goes into this tube. This tube has this cooling water, a lot like how a radiator works in a car or a truck. The radiator is designed to cool down the oil as it gets pushed around the engine. The oil absorbs the heat. When it comes to the radiator, cools off the radiator or cools off the oil, and then shoves it back over to the motor, which is creating a tremendous amount of heat. And this is the same idea. So when this steam comes up there and hits this cold water, it recondenses back into water itself. So it's not this water that we're looking at. We're looking at the steam coming back into water in this little area right here, and then we save it right here. So the distillation process is how we make distilled water. Okay? So distilled water is sold in many stores and used in canning foods, making baby food, and dietary substitute for tap water. Tap water is not pure water. Tap water is a mixture of all kinds of stuff that I don't even want to think about. But we drink it because it's safer than drinking it right out of a river or a lake. It kills a lot of bacteria and germs that are in the reservoir water. And then by the time it comes to us, it's clean. All right, now let's get back to those goats and sheep that I love so much.